Hi, good morning, everyone. It's morning here on my side. So, today's class would be continuing from it should be a kind of a continuation from what we did last time. That was communication protocols. Remember, we did something on SPI, I2C, and UART. And these three are the most popular ones. We have other ones like the CAN and something like that, and even USB. USB is a type of communication protocol. Yeah, that's why your phone can communicate with your laptop. That's why you can transfer files from your phone to your laptop. And remember that Type C, as I mentioned earlier or last time, Type C is a different thing altogether from what's the name? It's different from USB. Android cord also is different from USB. They communicate differently. They communicate differently, and these things they are not their ease of data transfer are different. So they have different rate at which they transfer data. iPhone code may be faster than normal USB code, and I've not checked yet, but it will be faster. So now, today we'll be going straight to work on one of the communication modules based on the project you were given. I gave you a project on what's the name now? I gave you a project to work on. That's offline voting system to work on, and this particular stuff we want to treat now, that's SPI communication protocol, which is um, which is used in the TFT screen. Because the TFT screen is part of your project, so I want to explain something about it now. I'm giving you the code for free so that you have a tentative idea of what I want you to build. You get. So we'll be going through this now. You will see how this particular screen works. Yeah, the connection have already been made just to make sure that the video is not too lengthy. That's why I did it this way. So I will just simulate it now. You see how it works. See, the code is already this walkway. This walkway in case you are joining for the first time. Yeah, you'll be following, Sha. I would put you through. I'll just be carrying you along so that you will not miss it. This walkway, this is the side you code. You code here, and this other side now you make your connections. Let me zoom out a bit so that you will see it in full. Okay, you see it, man. So this is it. Okay, let me open let me make this thing bigger, then run the simulation so that you will see it. Make it full screen. Zoom it in. So let me go and run it. If I run the code, don't worry, I will explain to you how it is connected. Let me just run it, you will see what will show up. So you see it's coming up. So this is like a simulation of TFT screen. Yeah, an example of SPI communication component or device. So it is for a fan. So the fan is on now, and we'll start reading from 1, and the fan will be running now. So when it gets a particular number, it comes back and continue from the beginning. So what I want to do, the way this thing is programmed now is the way I want to program your own. To have this interface, maybe candidate A, candidate B, candidate C, that kind of thing, on different rectangles, as you can see here now. That's what I want to do. That's why I'm using this example. So you see that the thing is already running now. So the issue now is, how was it programmed? How was it connected? That's the issue now. Yeah, so we're going to look into this together. Okay, I already got a prompt for that. Yeah, this is ChatGPT, as you can see. So I made a very good prompt for how it is, or it was coded and connected. So hello, bright minds. As you can see, I'll be reading through and then be explaining. You know me very well. I'm Tesla from Tesla Academy. We're offering a 1-month training from Bright Minds, in collaboration with Tesla. And in this session, we are going to explore how to write text on a TFT screen, as we did earlier, just now. We're also going to explore how to play around with it. How to play around with it in terms of graphics, adding colors, and even shapes. Just as the one we just did now. You saw the rectangles that are there. See the rectangles. You see the way they made everything stand out. So with this, I believe you can design that your offline voting system very well. You see the write-ups in different colors. So these are things we hope to achieve. We put them in different places. So these are things we hope to achieve. So you see, this project is our first Hello World in the world of graphic displays. Of course, you have not done anyone before. So this is the first one you are doing for the meantime. Now we understand how the code works, as I said earlier, how the connections are made, and we also learn the differences between SPI and I2C communication protocol. So moving forward, we're going to start by understanding what SPI and that I2C protocols stand for. That's what we're going to look into now. So there are two major serial communication methods we use in Arduino, and that's SPI and I2C. And the third one is UART. But we're talking about SPI and I2C here as our focus in this particular one. Now for SPI, there are four main wires. Anyway, you see these wires or these pins, you know automatically that these pins are talking about the serial peripheral interface. What are those connections or those terminals or those pins? One, we have the MOSI. The MOSI. I'm not interested in their meaning, but you can see the meaning here: master out, slave in. Then the MISO, master in, slave out. Then we have the SCK, which is the clock. We have the CS, which is the chief select. And whenever you see CK, it's always clock, or SCK is clock, but S there means serial clock. So these are the four major pins you see on SPI. Now in this TFT screen we are using, this is the number of the TFT screen, ILI9341. It uses SPI, which is faster. I mentioned it last time. It is faster and better for graphics because data transfer is continuous and high speed. So because of that, we use SPI communication protocol in TFT screen. So for I2C, I2C has two major wires: SDA, which is the data, which is the serial data, and SCL, which is what the serial clock. So you see that they share something in common. This clock now is also here, although the label is different. We also have the data and the serial data. And so these two now are the two major pins you find on your I2C. It is slower, but supports I2C is slower, but supports multiple devices with different addresses. You get. So we have examples like clock module. This RTC, real-time clock. OLED screen. There's a screen called OLED. It uses I2C communication protocol. So also we have what we call EPROMs. EPROMs are erasable electrical programmable ROMs. You might have learned that before in your course of study. So in summary, SPI are used for high speed display data, while I2C, when you want to connect multiple simple devices on the same two wires. So I can connect different devices now on just two wires of an Arduino pin, and it will carry all of them and work well. But then when it comes to SPI, you cannot do that. You cannot do that. It can't work. It can't work. Same thing applies to UART. UART, you cannot connect two things on the same wires. It can't work that way. So moving forward, we want to look at the connections. So these are the connections I will show you in the image. Normally, VCC is your 5 volts. In case you are joining for the first time, whenever you are dealing with VCC on Arduino or ESP, it's always 5 volts. Yeah. GND is ground, and all the grounds of a particular project must be connected together. I'm just doing it as a general studies now. Then in our case here, we have these other pins. Let me show you. See here now is our VCC. This is the ground. This is CS. This is reset, RST. This is this C. Then we have MOSI. We have SCK. We have LED. we have MISO. So these things now have where they are connected. Let's check this MISO now. MISO is connected to pin 12. Yeah, we have our SCK, that's the clock, connected to pin 13. We have our MOSI connected to pin 11. We have our D/C connected to pin 9. Then we have our CS connected to pin CS on pin this is the pin now, pin 10. We have our ground connected to ground of Arduino. Then the VCC connected to 5 volts of Arduino. So that's the connection. That's how the connections were made. So okay, I think let me take it as you said. I'm saying. So it's connected to 5 volts of Arduino. See, that's VCC is on 5 volts of Arduino. See it here. This VCC now. This wire now is a VCC connected on 5 volts of Arduino. So moving forward, let's continue with the explanation. So I've already explained the connections based on what is there. Now, moving forward, you can see other connections there on the listen, so you can check that one yourself. We want to look at the code now, how the code was written. The very first thing you do in Arduino is what we call getting the libraries. Yeah, the libraries you need. And for every sensors, most of the sensors uses a default or custom libraries. Some you can write without even using libraries, just like a project I did, just one project like that. Okay, I actually use time module library, but before, when I did it without time module, there was nothing like library there. I just did it empty. Everything was just pure coding. So these libraries help you to make it easier. And most of them without these libraries, they cannot even work. Like this screen now, you cannot do without the library. So these are the 3 libraries we are using. This is the default, how it is written. Even if you are a newbie, you're just coming into the space, this is not a big deal. You can just be getting your code from ChatGPT until you get or become good at Arduino or at using Arduino programming language. So these are the things that does. You can pause it and read all these things, what they do. And so each of the libraries have things that they do. Like the second one now is the one that draws that rectangle. And the third one is for the driving display driver display driver commands. That one that brought down that particular big rectangle. And then other things you are seeing there. So code explanation, we have the pins also are defined. Some of the pins must be defined, like the DC, the chip select, and all that. If you don't define them, what you need may not work. So it's important that you define the one that you need to define. We don't define VCC and ground on any occasion. We don't do that. We just connect them. We don't define them. But there are ones you must define. Some of them are by default. By default, there's a place they are connected. But these CS and DC, they are very, very important. You do what? You declare them. We call it variable declaration. So you can use this method. There's another method, but for the case of this project and for simplicity reason, we'll be keeping it simple. Okay, I think I should expand this so you'll be seeing it better. So we'll be keeping it simple for the sake of this project. So you can define also your colors and based on normal color coding. So define the colors you want to use using what we call the hexadecimal formats. So when you define them, that particular library that is in charge of colors or graphics, that's where those codings are. That 0 times that's 0x f80 and 0. I think you are seeing is coming from that particular library. Without that library, it will not work. So after you have done that, the next thing is the setup. The setup is one of the 2 most important functions in Arduino coding. You have setup, you have loop. That's void setup and void loop. So void setup is one of them. So these things now, they must be done inside the void setup. these two things you are seeing, TFT.begin, TFT.fill screen, if you don't do it inside there, and what you are doing may not work. You get, so it's important you do them. So the TFT.begin initializes the screen, and the fill screen fills the background color. Remember that big thing that came out that time? It was this thing that did it. This fill screen that did it. So you can read up. There are other things there you can see. Things like rectangles and labels are drawn using TFT.fillReact. Okay, sorry, fillRect. FillRect is simple now. It's normal English language. So fillRect now, you are filling it with rectangle. That's what it means. And for adding text now, how do you add text? Using add text. So that's an add text now. That's what helps you to do what to add text. And we will still see that in the code. I will still go to the code so that you see all these things. Then you saw that we added the text humidity using add text. Let me show you that. See it here. Okay, I think I have to stop this and then go back to the code. You see how we were able to get the text humidity using that. So just if you go down, you see where we did that. Okay, I think I have to make this one smaller. So you see how we were able to get, see it here. You said that we're able to get humidity to display on that screen using add text method. And every other thing here now you are seeing is just where it will start, like where it will be on the x-axis and where it will be. Yeah, just where it will be on the x-axis. That's why we use that. I use this s end. So we didn't actually use y-axis in the first one, but the next one had y-axis, s end, and then y end. You get. So and the color we are using for it is white. The color for everything is white, but I think there is one. Yeah, there's one that is that was green, which is the fan off. So see fan off here. Fan off is or was giving us what? See it here, was giving us. Yeah, fan off is red. Then we have fan on. Fan on is green. So when it becomes fan on, it turns to green. See it here. So I'm just explaining this add text, what it does. So this one now is a fill. So see humidity is white, fan off is red. When it turns to green, fan off will become what? It will become, yeah. Sorry, when it turns to green, it will give fan on. That's what I wanted to say. So you see now, that's what that particular function does. We move to the code, to the explanation again, making it bigger so that you see it very well. You see that we have for the first 3 seconds it displays fan off in red. For 3 to 10 seconds, the display updates fan on in green. So every 10 seconds, the fan on is being updated, and that's what you see from the rest of the code. But for just the first 3 seconds, you are seeing fan off. After 10 seconds, the program starts a counter that updates every second. So after 10 seconds, it will start counting. So then this one now is a function that was created to do some things. One, it set cursor. Like this thing I'm using now to point, this mouse pointer now. This, you see this stretch one you are seeing now is a cursor. This is a cursor now. This straight line you are seeing. I mean this my mouse now. You see this my mouse. See how it is now. If I come here to change. So the way it is now, it is called a cursor. So what sets that cursor? This is the thing that set the cursor, that make the humidity to shift and be somewhere. So humidity can actually be at this point, but because of the cursor that is set, it is making it to be some other place. And so this is what is doing that. Then the text color, this is what it's adding, the text color. This one is adding the text size. This one is printing the message. So this is what is doing that. So that add text now, this is the function of that add text. This is where we define that add text. So when anything we put here now will be the start on x-axis. Anything we put here will be the start on what? Y-axis. Anything we put here will be the color we want. Anything we put here will be the byte text size. Anything we put here will be the message that we want to print. Now, this thing you are seeing like this is called function in Arduino programming. This is how function is being created in Arduino programming, and you can create it anywhere. It can be up, it can be down, anywhere. But look at this one now we are using in this code. Let me show you something. I think I will make this code space. Okay, you can see it. Let me make it wider. Okay, making it wider now so that you can see it very well. So now this is the full code. This is the code. Now, what we're looking at was the function. So we have here, we have setup first. Remember I told you that the two basics are setup and what? And loop. These are the two major ones we have. Any other one we have can be used inside a loop as a function, like this add text you are seeing is a function that was declared and written somewhere. So this one is not really part of, okay, you can see, let me go down again so you see it. It's not really part of the major or the default function of Arduino. See it here. It's not the major, but then it helps to make your code smaller and much more understandable, like comprehensive. So if you see this thing now, this add text you are seeing, we define the function here, and then go inside loop or setup and call it. How do we call it? We use that add text to call it. See it here now. Anywhere I call it as add text, it would respond, provided that everything that is inside the add text, I define them, I declare them. The arguments, we call those inside the word arguments, and they must be the same thing. They must, like I must make sure that I declare all of them. I put all of them inside before it will work. Now the first thing is int start. Int y start. So where do I want to start on the y axis? I will put it there. So if you go now, you see that look at that one, the first one, this one now inside loop. You see that I want to start on 0.25 on x-axis. You get back? So I want, that's 0.25%. This one now, there's a way they did this one, it's a calculation. The whole of this now represents that S start. This one represents Y start. This Y end was defined somewhere, I don't mind. I can as well put something like 30 here, 40 here without doing this thing. So the color I want is red. Remember that after Y starts, the next thing is what? The color, text color. After text color, we have text size. So let's go and see. Text color, text size, and text message. So you see, I don't know if you saw that thing I just checked now. Okay, sorry. I said we have text color, see it here. And then we have text size. So let's go and check what is the text color, what is the text size. So in this case now, our text color is red. The size is 3. And the message we want is what? Fan off. So that's how you call the function. So if that function is called now, it will just give you all these things that's inside there based on the way you wrote it inside the function. Well, as time goes on, you'll be learning much. But I wanted to make sure that you are following so that you'll not be left out. So going back to the code. So all these things, this code now helps us to put everything in order. The cursor, the text color, the text size, and then the message we want to print. So everything here now would happen the way we want it. It will print this message on the TFT screen. That's why I think tft.println to print it in new line. tft.set text size, it will set it on the TFT and all that. So that's just the thing. So I think we are done. There's nothing much to explain again. That's all. So I believe that with this class, you have been able to understand the difference between SPI and I2C. Yeah. You have been able to understand that in SPI we have more wires, 4 to 5 wires, but I2C, the major wires are just 2. So when you see things like MOSI, MISO, automatically it's pointing towards SPI. MOSI, MISO, CS, and SCK. Those pins point towards SPI. When you see SDA and SCL, it's pointing towards I2C. We can connect multiple I2Cs on one DC to still work. When it comes to speed, SPI is faster, and why this thing is slower. What's the name? I2C is slower. So devices using SPI are fewer. We have more of I2C devices. As example, we have used TFT screen with the number ILI 9341 for this project, for this particular tutorial, and it's an example of SPI. For this I2C, we have RTC as one of the. RTC is actually a clock module. Yeah, so it's an I2C device, So it has the SDA and SCL as the major pins. So I think with this we can end this tutorial here. So if you have any question, you can ask. Thank you very much for your time, and may God bless us all through Christ our Lord. Amen.